Another for loop?
There's two choices, I think. Nobody seems to have come up with either of them. One is, we could build an iterator over our world, over the cells of our world, right? Nobody can stop us. We can take those two for loops and make a world, a cell iterator, right, that iterates over the cells of the world. Yeah? That absolutely is a thing we can do. What else can we do? Well, we can make a function that iterates over the cells of the world and takes a closure, right? It takes a function that does something at each iteration of the loop. Yeah? Oh, those are cool choices. I can either implement a trait or I can pass a closure. It's almost as though the things we've been talking about for the last week or so are not useless. Yay, not useless. Which one should we do? I am indifferent. How many people think we should make a new iterator? How many people think we should pass a closure? The closures have it by a wide margin because closures are easier. They actually aren't, they're about the same, but they're a little easier than that. So we will have a closure. So we start by building a new function. This is how this goes sometimes, by the way, is every function tells you another function. This sort of yak shaving is a thing. So for each cell, and let's be general, let's take a mutable pointer to self because we'll almost always have one lying around. And then what's the type of my closure? We'll just call it F, which is a terrible, no, we'll call it process. Or action. Action. That's a nice dynamic name. What should the type of action be here? Said you want me to have a function, a closure, what should I pass here? Should be fun, uppercase or lowercase fun. Uppercase fun. What would be even better than taking uppercase fun? Well, do I want the function to potentially be able to have a side effect on things? Mm-hmm. Sure I do. So maybe a fun mute would be better. I might as well. Mm-hmm. So what I want to write is fun mute. What should the fun mute take as arguments?
The thing you want to do?
Well, I mean, that's the thing that we're going to pass in as the function itself. But when I call my closure to actually do something with the cell, what does it need as arguments?
Probably a cell.
Probably a cell, the cell contents, right? What else? Needs its neighbors. Maybe. What does it need to know about where it is?
If it's a corner or not?
If it's a corner or not. What it really needs to know is the row and column, right? Now there's an interesting thing that's happening here. So let's do it this way for now. Let's say it takes a, what are the rows coordinates? U size, and mute bool, right? Now we have a closure, right? Interesting. By the way, there's a third way. I could just have the iterator return the rows and column, return a pair of row column coordinates, right? That's interesting. Let's keep going with this though. We've gone down this road. Once we've started down a road, it'd be always bad to retract. That's never a good idea. So, so how am I going to do this? Let's go back and look at our print function. By the way, do I want this to be and mute self? I don't think I do because I gotta be careful, right? It's really annoying. I'm gonna end up with two versions of this if I'm not careful, one for mutable and one for immutable. Let's go find our print function again. One other thing that prints the world, impl display for world, right? What is this gonna look like? This approach is starting to look ugly, right? Because here's our actual nested pair of for loops, right? And by the way, I'm gonna end up with, inner chords as the inner thing. This looks really hard to use. So here's the deal. This is a really reasonable path to go down. I think I'm gonna end up with for each cell and for each cell mute, both of which sort of repeat each other's for loop, which is super, super stupid annoying, but there we are. At that point, I start to rethink my life choices. And the thing where I return an iter that item equals a pair of coordinates starts to look better, right? And at that point, given that I'm only using this thing twice, once in the display loop and once in the world loop, and they look different, what's a logical conclusion here?
They can just be in.
That I'm just
Different
over-engineering, right? This is, you know, this is the dark side of copy paste, is I just went and looked at my pair of for loops I already have, and it's just a pair of for loops, and it isn't even the same pair of for loops I'm about to write. It's really, really, really easy to over-engineer in Rust, because they provides you the tools to do epic engineering. The right time to write this is when I need it for the third or fourth or fifth time, right? So I'm going to start with a copy paste here, but I'm not going to leave it a copy paste because copy paste is evil. I really need a different method anyway. What I'm going to write is something like this, and now we're going to have to get back to ND array. Right. All right, now we've got the row, column, and cell that we want to update. By the way, I've got a bare self.clone up there. That can't be a thing. And what is self.update? What have I written here? Oh, this is in the iterator. I'm in the wrong place. Sorry. Nobody said a thing. We're all getting tired here. I'm going to get rid of self here. This dot zero is no good. And now we're all up to the thing, right? So now I'm going to compute, right? I'm going to iterate over the old array, right? Producing row and column coordinates as well as getting the cell value from that array, right? Because it would be nice to know what my current thing is. That factors into the thing. Yeah, we all good so far? Notice how long this is all taking. I mean, people think programming should be done fast. Notice all the weird pitfalls and stuff we avoided by doing programming slow. I'm not a fast programmer. I'm not embarrassed not to be a fast programmer. You shouldn't be either. It almost always leads to good things. So we're going to do some kind of update there. I'm going to leave that for a minute. What are we doing? We're going to leave something for a minute. Leave myself a note. That's not implemented yet. then what am I gonna do when I'm done? What contains my updated frame? What do I want to contain my updated frame? Self. Can it really be this easy? Can I really just say pointer to self equals new? Is that a thing? Anybody see any reason why it's not a thing?
Wait, wouldn't you have 2 pointers? No.
New is just a new object, right? And I just want to stick it into the place pointed to by self, yeah? New what? Nobody sees any reason why this doesn't work? Anybody? No. Then let's assume it works. It works. It's just fine. It's this simple. It's the kind of thing you don't think of, but can really make your life easier when you think of it. We'll do the update by making a new copy and then overwriting the old one. Fantastic. What's the one downside of this? It's not correctness, but it's kind of slow. How come?
We're making a whole
It does a
copy.
stupid extra copy every time, right? I'm literally just copying for no reason, right? What I'd really like to do, rather than storing, making a copy, rather than moving new into self, is I'd like to update a pointer somewhere. What I'd like to do is what's called page flipping. This is the fastest way to do animation. Is you keep 2 pages around, right? And you read from one and write onto the other, and then you just flip the pointers. No, the pointers are the other way, right? Very, very cheap. And that's what you do in a real application. We're writing on an 80 by 24 terminal. This copy is going to cost us nothing we will ever, ever notice, I promise. So you're right, and that is an important thing to think about. But just like you don't over-engineer prematurely, you don't over-optimize prematurely. This implementation's simple. I understand how it works. Let's get this one working first. And then if it's too slow, whatever too slow is going to mean in this context, well, we can fix it though. All right. And let us do this part then. Oh, by the way, let's see if this compiles right now. We've done a lot of things. Yeah, that's fine. Oops. I misremembered my, oh right, I forgot to return an option there, which means I forgot to do a bunch of other things. Let's fix that. Next doesn't work the way you think it does. This is an infinite world, so I always return some self.clone, right? Because of course we do. And items from trait can only be used if trait is implemented and in scope. Defines an item clone. Oh, I haven't told the next iterator. It's complaining that it can't clone the world right here. Oh, why is that? Let's go look at our definition of world. Well, does it look like I should be able to clone the world? Do I have an implementation of clone for world anywhere? How am I going to get an implementation of clone for world? Right? Right, everybody? Let's all say it in union. We will derive the implementation. Yeah? Not enough people said that. That scares me. Please go read about deriving in the book. It's really important. So let's make our own clone implementation the easiest, dumbest possible way. It's like, yeah, hopefully array 2 implements clone. I think it does. So that problem should go away. Oops, I misremembered the
old.0.itercourse.
This function takes 0 parameters. I wonder if I have this theory. Oh wait, is that about this or this? No, old is, oh, maybe old not zero either, according, that is very possible, yes, that is absolutely right. Thank you. Somehow remove that, which I don't know how that works. No, because row is an array already, it's all good. Oh. All right, let's go look at the ND array documentation. And see if we can find this time the nice little implementation of highlights, performance, create feature flags, documentation, macros, structs, array base. I believe array base is where we want to be. An array base, blah, 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 indexing and dimension. Loops, producers, and iterators. That sounds pretty promising. Dot iter, dot outer iter, and dot axis iter, dot gen rows, dot gen columns. There's an iterator in here somewhere that also produced the coordinates. You know what? We're just gonna be dumb. Let's just do this the dumbest possible way. Sometimes you can spend too much time. There. Now, the problem is we're not getting the thing. Oh, wait, we know how to do that. We can just, right? We don't have to use anything special. We can just enumerate these because they start at 0 and go up to where we want them to go. Oh, I don't need that axis 0 anymore. Let's see if this gets us way up now. No blah for ND array, blah. Are you sure there was an inner outer here? Which I just saw it go by. Outer iter. I was pretty sure.
By the way, almost irrelevant question. Would this be possible to kind of figure out how to do in like linear algebra or something? Would that actually be faster if you did it with just doing matrix multiplications? Or would it not work with that?
It would be faster if I did it without matrix multiplication. There's no matrix multiplications here. I'm just using this thing to get a two-dimensional array. So there's lots of ways I could do a two-dimensional array. I could make a vector of vectors, right? I could make a single big vector and, define index with two tuples so that I got a two-dimensional array that way. ND array is essentially the fancy version of that as a crate. I'm just going to borrow somebody else's 2D array type because Rust doesn't do 2D arrays well. That's not a plus mark in the Rust qualified way. So here I just was being dumb and for some reason don't know how self works in things, so that's easy to fix. Right, and then there's a bunch of unused warnings, because of course there are variables not being reusable, it's hard to argue with that. Construct neighborhood, never used, never constructed. Hey! We have compiling bits.
Oh.
And the only thing it's whining about is we don't use a bunch of what we've built. Well, yeah, because that thing that says unimplemented, that's where the interesting code goes, right? So let's put the interesting code in. We've built a lot in the last half hour, 45 minutes. Let's actually make it do something. So I've got the row, column, cell, I've got all the things I need, right? So let's go look up the life rules and find out what it is we're supposed to do. Oh, well, first of all, what are we supposed to do? We're supposed to get a count of neighbors. Huh. Well, how are we going to get a count of neighbors? supposed to pass. Is the neighbor R in the neighborhood C, and what are we supposed to pass? Oh, that capitalized dims thing, right? We need to just tell it how big the thing is so that it clips on the right and bottom. Yeah? Does that look like the loop we want? Looks like the loop we want to me. I don't think this is the loop we want, but I think we want to do. What we want to do is count. Dot map. Right? What we want to do is we want to take the neighbors and we turn trues into ones and falses into zeros. Yeah? And we're guaranteed that the array referencing will work, right? Because we're guaranteed that all this is inbounds, right? So let's deal with it. Old sub R comma C as U8, let's say, because there's only going to be at most 8 neighbors. Yeah? Oh. Dot sub. Cool. Instead of writing some weird fancy for loop, right? We just write a closure. Like, yeah, that closure will get us where we want to go. Yeah? Maybe. Who knows if it works, right? But it looks like it ought to work. We make an iterator. We iterate over the elements. We add them up. Now we got the number of neighbors. Sweet. Well, so like I say, let's go look up the life rules because now we're going to need to do a thing. But before we do that,